So we are Project Mood. We did a sort of AI to explore emotion detection algorithms. I am Jackson. This is Kiana, Claire, Kelly, Steven, and Maria. That's our team. So when we walk, we were situated in the alcove over there, a bit tucked in the corner. When you walk to our booth, what you would probably start seeing is these posters. So I'd like to explain our project the same way as someone who visited us would have seen it. So you start off on one of the corners. We have an intro to facial recognition and emotional recognition. And we chose facial recognition because it's a technology that has been proliferating slowly throughout our lives in recent years. Take Facebook, for example, like tagging pictures. That uses facial recognition technology to suggest tags. Or smart cars with their fatigue detection. That also takes in images of your face, and according to some data, it tells you if you're tired or awake enough to actually drive your car. And obviously iPhone X with their revolutionary unlocking mechanism, which take a picture of your face, you can unlock, you get access to all your data. So that's the first poster that people would see. And then later on, we talk about collecting data sets, and I'll actually move forward.
Yeah, talking a lot of going through a very basic process, collecting data sets and how data impacts algorithms and how they learn. Going from there, actually looking into machine learning and how that ends up working. Afterwards, we go into a bit about bias and automation bias and how that impacts the results of these algorithms. And then finally, we talked a little bit about impacts. However, the more important part is that the fact we had an interactive demo. It's a very, very simplistic symbolization of the way that these types of algorithms work. So we had them in little black boxes as a way for privacy, and also to kind of talk about the way that algorithms are a black box. And our whole project is trying to break into that black box and showcase everything that goes on inside of it. So basically, when you first start off the demo, we have a little explanation as to what machine learning is and what this whole demo would be. So after reading this, you would get into a point where you can select a data set to train your emotion detection algorithm. This particular algorithm is looking at whether a face is happy or not. So after selecting whatever data set you would like to, you can then go on to select the test data. We had a few selections there, but you could also upload your own picture. Upon which, after selecting whatever one you're testing, it would give you results. From here, I'm sure many people recognize who this is. So from here, people can compare what the result is to what you originally thought when you selected that picture. Did it match up with, did you think that this picture was happy or sad? Did the results actually match up with that? And then more importantly, engage it with some questions as to why that could have happened. And how you think the results would have changed. And therefore, by restarting, you can experiment with that and see how those have differentiated. And a little bit behind the scenes of the technical side of things.
So our model is training convolutional neural networks, and this model is serving as a key to a happy house. If you're happy, you can go into your house. If you're not happy, then you have no access. So there are three data sets we're choosing. The one is kind of the relatively unbiased data, and then we have two other biased data, which the first one is the Asian women's, and the second one is all the images with the glasses. The model the API we're using for the model is Keras. Keras is a neural network API written in Python, and we run it on the TensorFlow framework. And also, Keras supports the rapid prototyping. So these attributes can help us try out different models, architectures as much as possible. Finally, we can get the accuracy we want. Also, we are training our model with GPU, which increase our running time speed up by at least 3 times. There are 4 main steps for training a model. The first one is creating. Creating is the step we need to decide the model architecture. For example, how many layers we want and which layers. The second step is compiling. Compiling is trying to check whether there's any syntax error of the model we just built. And the next step is feed and train. So here, we are feeding our data sets we selected into our model and then train the model on that data sets. The final step is evaluate and test. For here, we can get the results. We can get the runtime and the accuracy, and also we can get like final results. The final product is you input an image you have just taken by yourselves, and then the model will predict whether it's happy or not. So this image our model predict is as 1, which means it's happy.
So I think after all that technical stuff and just going through, why project mood is probably the most important question. So the reason why we chose this was because we want to examine bias in algorithms and how it impacts our everyday lives. We want to use a case study that was relatable to us, to the technology that we engage with, to the environment that we're in. And we also wanted to use interactive components to engage with our audience more directly, because as much as information we can put in didactics, oftentimes it's much more effective to have a direct engagement with the material, henceforth our demo. And generally speaking, our takeaways, this is not meant to be a project that is supposed to provide the solution for all these things that may happen, with all the biases that will occur in these types of algorithms and the impacts it will have in our everyday lives. What is more important is looking at how we can educate people about it, make it more accessible, and therefore spark conversation so we can all start addressing these issues. So we wanted to kind of have these general takeaways, the fact that facial recognition technology is present in all everyday of our lives. Algorithms learn based on whatever data sets they're given, so data collection has a large impact on the results. And then therefore bias in data sets affect results, and automation bias prevents us from seeing them as we place a lot of trust in that data and algorithms and results. And therefore, any decisions made by these algorithms and influenced by these biases will have a big impact on our lives. That's pretty much it. A big thank you to our instructors, Ian and Marcel, and of course to our speakers, Mimi and David. Thank you very much. And of course to Ina for helping to organize this. This was Project Mood.